Hello everyone, I will start with the introduction. The Form 2 Science Curriculum or the SKP is developed under the KSSM framework and serve as an important to guide help students develop scientific literacy. This curriculum doesn't only focus on teaching science fact, it also aims to prepare students for real world challenges, especially in this era of the fourth industry revolution and sustainable development. Students students are exposed to various scientific fields such as life science, physical science, and universal science. At the same time, the curriculum puts emphasis on value, ethic, and attitudes, shaping students into responsible individuals. In this project, we analyzed the curriculum using Tyler model, which focus on four main questions. First, what are the educational goals? Second, what learning experience are provided? Next, how are this experience organized? And last, how we evaluate if the goals are achieved.
Okay, first I want to tell about curriculum analysis based on the Taylor models. First, educational objective. The science form 2 curriculum aims to introduce students to basic scientific concept while nurturing important values such as curiosity, critical thinking, and responsibility. This objective are aligned with the national education philosophy, which emphasize the development of students intellectually, emotionally, spiritually, and physically. Science education in this context is not just about acquiring knowledge, but about shaping students to become responsible and ethical individual who can contribute to society in the rapidly advancing uh, scientific world. Okay, next, learning experience. Students are exposed to various activity learning experience, including hands-on laboratory works, group projects, team-based inquiry tasks, and real-life problem solving. These activities are rooted in constructivist constructivist learning theory, especially Brunner uh, 1966 discovery learning approach, with student will their one understanding that exploration. This method encourage the development of core 21st century skills such as critical thinking, communication, collaboration, and creativity. Touch activity participation. Students become more engaged and motivated to explore the worlds of science. Next, organization of learning experience. The science form 2 syllabus as a spiral curriculum structure. This means that scientific concepts are received multiple times each time at a deeper and more complex level. This approach, supports by us idea of possible 968 and Browner, helps students reinforce they understanding by connecting new knowledge with what they have previously learned. Um, the curriculum covers three main branches: life science, physical science, and earth science. These branches are interconnected, allowing students to see the relevance and overlap uh, between different scientific area, which helps strengthen the overall scientific framework. Last, assessment and evaluation. This assessment system is used in Form 2 Science in Kaling Rantaksiran Bilik Darjah PBD. It is a classroom-based assessment approach introduced by the Ministry of Education that includes both formative and summative methods such as observation, quizzes, performance tasks, uh, performance test and student presentation. According to Black and William 1998, formative assessment provide continuous feedback that support both teaching and learning. PBD not only evaluates what students remember, but also how well they understand and apply scientific concepts. This approach makes assessment more meaningful and relevant to real-world learning. Thank you.
Now I will explain about foundation of the curriculum. The Form 2 Science curriculum is built on three important foundations, that is philosophical, psychological, and sociological. These help shape the way science is taught, making sure it's not just about content but also about developing students as responsible, thinking, and ethical individuals. The first one point is philosophical foundation. This foundation is based on Malaysia's Falsafah Pendidikan Kebangsaan, which promotes balanced development intellectually, spiritually, emotionally, and physically. Science lesson encourage students to use knowledge ethically, for example, by learning to care for the environment through topics like pollution and sustainability. The second important foundation is psychological foundation. The curriculum is supported by theories from Piaget and Vygotsky. Piaget explained that students at this age can think logically and solve problems, which is why activities involve experiments and critical thinking. Vygotsky theory highlights collaboration, so the curriculum includes group work and peer learning to help students build knowledge together. Last but not least, the importance of the foundation is sociological foundation. Science is connected to real life social issues like climate change and public health. This teach this teach students to understand their role and solving problems that affect society. The curriculum also promotes teamwork and unity by encouraging collaboration across different backgrounds, preparing students to be socially responsible citizens.
To conclude our presentation, this science curriculum is more than just learning facts. It helps students become confident, curious, and responsible. Taylor models show that the curriculum has clear goals and good activity to support learning. It also uses important ideas from education, like thinking skill, teamwork, and real-life learning. In short, this curriculum gives students the knowledge, skill, and value they need for today's modern world.
Moving on to appendices. Appendix A, which is content and learning standards, shows the learning standards under the ecosystem chapter in Form 2 Science. Students are expected to understand both biotic and abiotic components in an ecosystem and how they interact. They also learn how human activities can disrupt ecological balance and how we can take action to maintain it. These standards help guide teachers and ensure students gain both scientific knowledge and environmental awareness. In Appendix B, we included a hands-on activity titled Building a Mini Ecosystem in a Bottle. The objective is for students to observe how living and non-living things interact in a closed system. They use simple materials like soil, plants, and insects to stimulate an ecosystem. Over 7 days, they record observations such as plant growth, condensation, or insect movement. This activity promotes real-world learning and critical thinking. This activity also builds important skills like observation, recording data, teamwork, and environmental awareness. For assessment, students present their findings as a group, keep individual journals, and are evaluated using rubric. This method encourages both collaboration and self-reflection while also connecting textbook theory to a real environment. For the last appendix, Appendix C, which is curriculum mapping, Appendix C provides a curriculum mapping table to show how learning objectives are linked to specific activities and assessment methods. For example, when the objective is to define an ecosystem, students build the mini ecosystem and are assessed through observation and reports. This follows Tyler's model, which emphasizes that goals, experiences, and assessments must be clearly connected. It ensures that students are not just learning, but are learning meaningfully and in ways that can be applied. Thank you.